Okay, so my fans, if you do engineering, you need this particular one. If you want to study physics, you need this particular one. Make sure say you like this video. If you want my break and down well, like I'm now. First, like an anytime you wear this cap, you may say I want to do circuit stuff. Because the engineering people they like those circuit analysis. Make you so one. So if you never subscribe. What you will do for this particular question? The question like within the simple. They say make you find the effective capacitance between points X and Y in the figure below. See the figure. I mean, they say the effective capacitance between points X and Y in the figure below is question mark. So make you find the effective capacitance. Now, they don't just stop there. They still they tell you, say, assuming that C2 is equal to this C2 here, 10 microfarad, and all other capacitors, they mean C1, C4, C3, C5 are of 4 microfarad. So this one 4, this one 4, this one 4, C4, this one 9 is 10 microfarad. Now you see say they don't give you things where will make you fit solve this thing. The first thing I will do, I will withdraw this particular circuit because the way it did like this, it's difficult for me to run them. So I will redraw them the way we see go clear for my eye. First thing I will do, I'll say this point X like this, as it be like this. This point X now, carry this, I will carry this C1, go up. You know, say here na point X. I'll carry this C1, go up like this. I not too savvy draw, so the diagram no fit dey nice, but I will tell you wetin this stuff will result to. This C4 will dey like this. This C4, I'll carry and come down. So I'll carry and come down like this. Here. Then the next thing now, see, I'll show you something. From this point to this point, and from this point down to this point, you notice say C1 there, C3 there, C4 there, C5 there, and C2 come be like say dey middle. C2 na in dey middle because see am now. C1 there, C1 there, they dey by the side. This one there, this one there. This one come connect reach here. This one come connect from here, reach here. To tell you say C2 na in dey for the center, the middle. So yeah, from here now, I come carry C2. I will come here like this. Say, okay, C2. I don't know why my hand is straight to draw. Draw your own well, oh. You look me like that. So I will come here, say, this one now will be the C2. See, you know, reach. Good. So now I will put this one. This one we agree saying as C1. This one we agree saying as C4. Here as C2. We never finish. Oh. This particular one, we get C3 here. We still get C5. I'll carry this C5 come up like this. So I'll get C5 here. Then my shift and come down small. Then this particular C3 come down here. So from down here, I'll get a straight. Even if you don't straight, maybe manage them. I tell you, I'm not a big draw. You make your own straight. Hey! So here na C waiting. Here na C3. Here na C5. My fans, if you look this thing where this particular one, I bet they call Wheatstone bridge. I bet they call Wheatstone bridge. Name this one. And for Wheatstone bridge, they can't give you instructions. Say this C1 now 4 microfarad. Say and all other capacitors are 4 micro. This one has 4 microfarad. 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 Now this one 9 be 10. And for Wheatstone bridge, if this one has 4, 4, 4, 4, it means that the bridge don't balance already. True or false? Talk now. True or false? If you have 4 microfarad, 4 microfarad, 4 microfarad, 4 microfarad, it means say this Wheatstone bridge don't balance. So we don't need this particular charge. No charge go there for this particular capacitor since the Wheatstone bridge is balanced already. So what you will do, you will delete this guy come out. You will delete this C2 come out. It shock you. So you see the Wheatstone bridge like this now, it balance because this one 4, 4, 4, 4. Now if you calculate, because that one we did there, even barrier will go make you tough to calculate this thing. So As it be like this now, you notice something. You notice say C1 and C5 dey in series. You still notice say this particular one, C4 and C3, they also dey in series. That means this one is in series, this one dey series, but this one go dey parallel to this particular one. Because I fit still redraw am, straighten this one like this, straighten this one like this, get this particular terminals like that. So I can't get am like box, like this way box dey. Get C1 there, get another one, C5 here, still get 2 for this particular place. It means say this one dey series, this one dey series, but the two of them will dey parallel. So wetin we go need to do now na to resolve this one in series, and then this one in series, then their result and their effective capacitance in parallel. Make we run am. So wetin be the formula to calculate this particular one? If you wan calculate capacitors in series, you go use this formula. Make I use prime notation. I wan calculate the equivalent or the total or effective capacitance of these capacitors connected in series. So I can use C prime to represent the effective capacitance. The total capacitance will equal to, I go multiply this by this, C1 times C5 over C1 plus C5. How I take get am? For capacitors in series, see the formula. 1 over C, may I use prime, maybe C total, or you're used to C total or C equivalent, equal to 1 over C1 plus 1 over C2. That means the formula normally. So if you look for LCM of C1 and C2, and they derive all these things, it will be C1, C2. Or shortcut, if you want to look for, if you want to solve this fraction, C2 times C1 will be C2 plus C1 times 1 will be C1 over C1 times C2, C1, C2. Then here now 1 over C total. When you shock say you know resemble this one, now because you get as 1 over C total, no be C prime. So if you flip this one, inverse of C total means say turn it upside down. That means C total now will be equal to, I will flip this one too. If you're flipping the left, you will flip the right. It will be C1 times C2 over C2 plus C1. You see resemble. So you don't go bother to go follow all this route, all this process. Just use this one. If you see one, use this one, no wahala. Just make sure you put the value of this one. All of them. Yeah, no be C1 and C5. I just use example. Okay. So all of them are 4 microfarad. Don't forget. So if you use this one now, C prime now will be equal to 4 times 4. Remember all the capacitors, each of them are 4. 4 plus 4. 4 times 4 now 16 over 4 plus 4, 8. And 8 divided by 16 divided by 8 will be 2 microfarad. It will be 2 microfarad because, yeah, now 4 microfarad. Like we no change the microfarad to farad. So your unit go there for microfarad. So you understand how to get them now? Good. I don't solve for this particular one. Make a run for this one. I will use C prime prime for this particular one, equal to the same thing. So I will get C4 times C3 over C4 plus C3. So everything at 4, 4, 4 now. So I will say 4 times 4 over 4 times 4 plus 4. It will still give you 16 over 8. Maybe 2 microfarad. Now the final thing what I will do for this particular place now to add these two. Remember say capacitors in parallel. When I don't resolve everything finish, this circuit now will come there like this. Cx x. The total I get for this place. I say this one now 2 microfarad. Maybe C prime. Here now y. So I will still get here like this. Here now C prime prime, maybe 2 microfarad. You understand what I mean now? You see say this one and this one, they in waiting in parallel. And parallel connection, make you use C prime prime. Make you use C prime prime. I use this place. C prime prime prime. I don't use C prime, C prime prime, C prime prime prime. Will be equal to the total of this one. And they are connected in parallel. So I will just say C prime, then get this 2. C prime, then get this one, plus C prime prime. If you don't like to use C prime prime, if you use anything where you like, fast see the follow up, no wahala. So the value is now 2, 2. So 2 plus 2 Put the unit outside though. This one will give us 4 microfarad. So it means that the effective capacitance between point X and Y, between this point X and Y, are waiting at 4 microfarad. That is the solution to this particular problem. And I hope say you find this particular video helpful. Just support me by hitting the like button. If you hit the like button finish, share this video, make other students learn. Respond if you sabi wetin dey talk. You know sabi? Okay, check comment section, people will teach you how dem dey talk am. So now so it take be. If you want make I do videos on other area or more examples on these exercises for this electrical engineering circuit theory textbook, tell me when I bring more questions. If you want for superposition, Thevenin's, Norton's theorem, Macmillan theorem, any of the theorem we want for physics, tell me for comment section. I will find time to do video for you. My name is Instructor Alison, a math and science tutor in Pidgin English, where they make these things where they hard simple through the language we only you feel understand. Now wetin the brand represent. So mark comot now, share the video and like them. Don't forget to like them. Subscribe if you never subscribe. Peace and love.